Good afternoon. We're going to have a talk here starting shortly. I'd like everyone to kind of find a seat. If you can, move up closer so you get a little better of a presentation. I know in the back sometimes it's kind of hard to see this, and we tried our best to get the projector out. So I wanted to let you know about Fedora, who is sponsoring this room. So as you know, it's like we charge very little to actually get into this conference, and the sponsorship is very important to being able to pay the rent, basically. So Fedora is a fast, stable, and powerful operating system for everyday use, built by a worldwide community of friends. Completely free to use, study, and share. And you can learn more about Fedora at the fedoraproject.org or visit their booth on the Expo floor, which is booth 57. They've got Fedora CDs to give out, live CDs, so do check them out. And now I'm going to introduce you to David Nalley, who will be talking about Gluster file system for SysAdmins. Thank you very much.
Hi, folks. So you can see email address and Twitter if you want to get in contact to me, or if you wish to berate me publicly during the presentation as well. So really quickly, who I am. I'm a recovering sysadmin. I worked in operations for about a decade, and I got out of that to start working on CloudStack and kind of hopefully provide some operational sanity to the folks building an infrastructure as a service platform. About a year ago, I joined the Gluster advisory board. I'm a little bit of a distributed storage junkie, so I'm a Fedora package maintainer as well, and I maintain Ceph, Sheepdog, and ironically, I do not maintain Gluster at all, but involved in a number of different distributed storage efforts, so Ceph and Sheepdog. I've got a couple of patches in, and again, ironically, no patches in Gluster yet. So, I also, you will note that I am not Echo. If you saw the old schedule, Echo Wilson, who is actually employed to work on Gluster full time, was scheduled to give this talk. He is probably far better qualified than I am to talk about Gluster because that is his sole focus every single working day, and it is not mine. I have been a user of Gluster and now work a little bit on the project. I also make ugly slides, so if you're expecting things of beauty or even cat pictures, you will be sorely disappointed. So, a couple of questions for you as we get started. How many people here understand the relationship between LusterFS, GFS, GFS2, and GlusterFS? Okay, there is no relationship at all. They share many common letters and quite honestly cause a lot of confusion, but these are all completely separate code bases. Anyone using GlusterFS today in production, or GlusterFS period? No? One? Okay. How big's your storage? 2 nodes? So I'm going to try and, network willing, do some demo work with Gluster and show you how to set up 2 nodes. Anybody else using any other distributed storage? So, okay, what are you guys using? Mm-hmm. Mm-hmm. Okay, I saw 2 other hands. What do you use, Jason? Oh, okay. Proprietary distributed storage, but still very nice storage. Yeah. Anyone else using something interesting? Ah, yes. Okay. Okay. Isilon, I don't know if it's Southern California, but Isilon is very popular, it seems, with a lot of folks here. I was talking to someone else who's using Isilon yesterday. So there's a couple of other projects out there. Ceph, obviously, which has a little bit different focus. There's Sheepdog, which is just block storage for virtualization. There's OrangeFS, which is using TVFS2, and there are a couple of others out there that are notable in open source realms. So, real quickly, a high-level understanding of what GlusterFS is. It is a distributed network clustered file system, which is a lot of buzzwords. Essentially, it distributes storage over multiple nodes. It may replicate rather than truly distribute that storage. It may stripe, a number of other things. We'll talk about some of the various options there in a bit. It's written completely in user space, and that's strange. It is, as far as I know, unique in the distributed file system world for being in user space. And when I first was introduced to Gluster, and they told me to use the Fuse client, I said, yes, but then what do I want to do when I want performance? Because we all know that user space sucks. Really, the folks who started working on GlusterFS, and don't laugh when I say this, we're all GNU herd folks. And so they have this microkernel focus and everything else is in user space mentality. And surprisingly, they've been able to make this work. And they really have proven this in production at massive scale. So really, this started out its life as what was going to be a batch computing exercise. So oil exploration for a government agency in Venezuela was the impetus for starting this. And the company really didn't want to be a file system, a storage company. They wanted to be they wanted to focus on being able to do massive compute jobs. And it turns out that their limitation was storage, and they looked at some of the alternatives out there and found a lot of problems that simply couldn't handle the scale that they needed, and ended up writing GlusterFS. And today, how many people here use Pandora? So Pandora runs on GlusterFS. All of the songs are stored on GlusterFS, and that's one of the larger deployments in production that I'm aware of. So essentially, Gluster is going to provide you with the ability to scale out NAS on commodity hardware. It'll also provide you with object storage or HDFS compatible storage if you want to do HDFS or run MapReduce across objects in your storage. And one of the things coming up in 3.4 is actually decent block storage. So some of the folks at IBM have been working on Gluster recently and working also in QEMU and libvirt to make it possible for running virtual machine images on Gluster and make that not suck, because it really sucks right now. Performance gets awful when it scales up to a few nodes. I've actually had a number of folks using CloudStack who wanted to use GlusterFS as their storage for virtual machines, and it works fine at low levels, and you try and scale that up and it starts falling apart. And so the folks at IBM have been working a lot on that recently, and I think 3.4 will provide that so that it's actually consumable at a given scale. So let's talk a little bit about terminology. We have volumes, and this is just like any storage volume. This will essentially become your mount point. It's where your data is stored. But in Gluster, this is made up of a brick, and the brick actually will have a file system running on it. So you need a file system that supports extended attributes, and the preference hopes to be ButterFS as that underlying file system. But everyone who says that says, oh yeah, but you shouldn't do that yet. ButterFS, I think, will offer a lot of compelling functionality once it gets a little more stable and has working file system checks and things like that. But essentially, each one of those bricks is a set of is a file system on a discrete node. You may have multiple bricks on a single node, but that you may be impacting performance there. But the assumption is, generally speaking, that you're going to have a brick per node, and that you'll assemble those bricks to become a volume, depending upon your strategy of replication or striping or distribution. So I wrote this, and then I realized that I am from the Southeast, and I understand what Waffle House is. And this is funny to me, and it won't be funny to anyone else. And I would have put in the link to the Waffle House menu, because it would have been even more funny. Essentially, people talk about a distributed storage system, and that means a lot of things to different people. So the menu options really for Gluster are this. So you can distribute, and that means that you're distributing files, an entire file, onto bricks. And that means if you've got 2 bricks in your volume on 2 different machines, file 1 will go to one machine and file 2 will go to the other, and it will distribute the files quasi-equally, trying to load balance them across the bricks. But the files will all be in a single place. So if you're looking for file 1 will exist in its entirety on a single machine. Confuse anyone yet? Because it gets worse. So replicated. Replicated is probably the easiest and I think the most useful option, especially at a small scale, because effectively I can replicate all of the data across bricks. So if I copy file 1 up, it will exist on both bricks, assuming I'm only doing 2 replications. It will exist on both bricks in the volume. So if one goes away, I can continue to access it. I may not even know that it went down. So then we have striped, and striped's really designed for places that have large files. So if you have 15 gigabyte disk images that you wish to store and you wish to give relatively fast access, you can have multiple machines and that file will get striped across it. So if you have 3 machines, it's going to divide that one 15 gigabyte file into 3 5 gig chunks, and that way you have all 3 machines feeding the file back when you need it, which hopefully gives you a little faster throughput. That, of course, doesn't give you any redundancy, and so losing a single node will mean that you have no data, just like it will in distributed. You would have half your data or a portion of your data if one of them went away. They are mutually exclusive, sort of. So you could do one of those 3, or you could do something like distributed stripe, which is a combination of distributed and striped. It's going to require more nodes because you're doing both striped and distributed, and so you get the benefits of both striping and distribution. You can do distributed replicated and distributed striped replicated, but you'll notice distributed replicated is okay. You're distributing the files across multiple machines, and then all of that's replicated to another set of files or another set of bricks that are distributing the files across another set of machines. So you can do that. You're obviously going to need a much larger number of nodes. And then we start getting into a little more esoteric things like distributed striped replicated. And currently Gluster says you should only use it for MapReduce jobs. You should not be using this for anything else. And so it becomes distributed striped replicated So you're spreading the files out, you're splitting the files up and spreading them out, and then you're making a copy of all of that. I don't think MapReduce is really the only application. That's the only thing that they feel comfortable telling you to use it for at the moment. And that is essentially with the hope that you can replicate all the data. Because I think this increases complexity to a point where it starts becoming a little more uncomfortable. And you have the same issue with Stripe replicated. The official GlusterFS position is that you should use this for MapReduce only, even though you're replicating all of this, and theoretically this gives you much faster access to large files and still have a safety net there. Any questions about the various options? Yes. So you can specify how many copies, how many times you want it replicated when you set up the volume. So you can say, this is going to be a replicated volume, and I wish to have 3 copies, or 15 copies, or 2 copies. You can't obviously drop below 2, but 2 and up that are valid integers will work, provided you have enough nodes to support that. I don't think you get a whole lot of benefit past really 3, because you're essentially talking about single nodes, and unless you're doing distributed replicated, you're not really able to increase the volume size past what a single node can store because it's all replicated. So I think that there really is a point of diminishing return there. That you want to step up to distributed replicated. Yes?
How elegantly do nodes fail?
Nodes always fail completely inelegantly. How does Gluster handle the failure? Generally speaking, you don't know that the failure has occurred, assuming it's not a completely catastrophic failure and not something that gets you to the point where you're not where you don't have access to everything anymore. So we have this concept of a quorum. So essentially, if to deal with split brain situation, you can specify a minimum number of nodes that are necessary for that swath of storage to consider itself canonical and to continue to be writable. If it doesn't have quorum, it'll go into read-only and wait until it rediscovers the rest of the nodes. It has self-heal, so if you have a network glitch and lose half of your nodes for 10, when they come back online or become visible again, it will begin healing itself. That takes a minimum of 10 minutes to start. It polls every 10 minutes to see if there are things that need healing. You can also do that manually. Generally speaking, it's relatively robust as far as handling failure. Of course, it's never perfect.
Is it sitting on top of a cluster manager like Gluster, or is it
doing it all itself? So the peers, the nodes will know about each other, and they all know of the other node's existence. When nodes disappear, one of the downsides is that they don't automatically rebalance. We'll talk a little bit about that in a little while. It's one of the downsides. But essentially, the nodes all know about each other. One of the problems that you tend to run into is that it will hash the file that you want, and it will try and find it where it thinks it should be. And if it's not there, it says, wait, there's a problem here. I don't have access to that file where I think it should be, and it has to go searching. So you tend to end up, particularly if you're doing something other than straight replication, you tend to end up in a situation where read access drops dramatically because effectively it can't find things. You save you save a little bit of that if you're just doing straight replication, but when you start doing striped or distributed on top of that, it starts becoming more of an issue because it's going to look for nodes where it thinks the file should be, and it can't find that node suddenly. Any other questions? All right, so you can also do GeoGratification. This is unlike the other replication. So the replication we were talking about earlier is synchronous. You can specify a cache, but essentially when it says the write is done, it's written to all of the nodes. And that's very useful unless you have a truly catastrophic outage that takes out all of your storage. So essentially, if you want to replicate somewhere else, you can do this asynchronously, and you can configure how asynchronously that happens. So minutes, hours, days to sync, and essentially have a copy of all of that storage at least at a point in time. And of course, you can do that to more than 2 sites. You can. There are a number of places who are replicating to 4 or 5 different data centers. Yeah, that is at the volume level. So it's essentially any of the configuration options is done at the volume level, and all of the tuning is done at the volume level. So you essentially have completely discrete configuration of things. There's very, very little done globally. So user space really doesn't suck, and I say this tongue in cheek sometimes. Ignore your bias until you try it. There are workloads that GlusterFS is not good for. You do not want to run a large database off of Gluster. That is not its core arena of performance. If you have lots of small files, great. If you have lots of large files, great. Even if you're write heavy, that's fine. Making lots of tiny, small changes to very, very large files is where Gluster starts to break down. And it's one of the reasons that, for instance, historically they've had problems with virtual machine images because that's lots of small changes to little files. And the way they've got around that is they're starting to do that as a block device now. And that's going to, I think, dramatically improve that performance. That is in still a yet-to-be-released version, though, so I would not assume that you can go out and do that tomorrow. Although folks using the 3.4 alpha would be encouraged to break it so that when it's released, it does not break. There are regularly people, though, who are doing incredible things, depending upon with regards to distribution and or striping, and are getting incredible performance, essentially able to compete with some of the proprietary storage heads. And essentially, they can scale that much cheaper and at least presumably increase performance. So one of the things I haven't talked about is typically if you use anyone using parallel NFS? No, everybody wants to, right? It's one of those unicorns that we've been talking about for years, and maybe one day we'll actually see. So parallel NFS and a number of other legacy distributed file systems use what is a metadata server. So essentially, I want a file. I will go look up on this machine where the file resides. That machine will tell me which file I go query and get the file from. Parallel NFS does this. OpenAFS, I think, did that as well in bygone years, and Gluster certainly did. So Gluster's concept is that you will essentially be doing hashing of the files constantly, and that's how it's going to determine where a file goes. and that's also how it's going to start feeding the files back. So there is no head node. There's no head to essentially kill off. And this has become the norm with distributed file, next generation distributed file systems. So you'll see that same type of behavior in Ceph, for instance. Yes. Yes. Right. So you can specify multiple nodes in your mount, so that if you lose one, you will continue to get others. So you can also mount, in addition to doing a native Gluster mount, which, as strange as it sounds, is Fuse. In addition to doing a native Gluster mount, you could also do NFS, which has that exact problem. So you effectively can't, you can only point it at one place, and you would have a problem, but you could specify multiple endpoints, even though that seems like the wrong terminology, so that you don't have that problem when you're mounting that file system up in the first place. I probably would. Not that you will notice. So it would, where you would run into that is when one of them failed until it started speaking to the others consistently, because you would have the timeouts initially, right? Exactly. It's far more acceptable. Can you put it behind what? No. Well, I say no. So there are essentially proxy agents that are designed to do that, but they are designed for object storage. So they're called object storage gateways, and probably not really what you want if you wanted to mount the file system. You would mount that instead. You can also use DNS names though. So that's, but not, well, you could probably do. There's no stickiness requirement. So I think it's better for you to have stickiness, because it's going to, if you have multiple nodes specified, it will go to the right node for files when it figures that out. And otherwise it has to start searching the nodes for the file that you're looking for, which is a little more expensive. All right, so here's the bad, and these are the bads from a SysAdmin perspective, because there are lots of problems with any distributed file system. My favorite GlusterFS T-shirt says, "Your distributed file system sucks," and it's true in some regard of every distributed file system. If you want to know all the things bad with distributed file system from a technical perspective, Sage can tell you all of them. Sage is a Ceph guru and works for Inktank, so he is one of the competing distributed file systems. That said, log rotate is not automated, and that sucks. If you want to rotate the logs, it has you calling a command to do so per volume. Start thinking about scaling that out, and you're either cronning that. It's just awful, and that is the most appalling thing you'll read in the administration guide. The other is that rebalancing is not completely automatic. So as you're adding nodes, because I think the assumption is that you would not start out with a deployment that is going to be able to serve you for N number of years. You may start out small, you may start out medium and need to add capacity or additional redundancy, and that's completely possible. That's one of the benefits of using an open source distributed file system, is that you can continue adding nodes and essentially continue adding capacity and hopefully performance along with those nodes. The problem is that it starts calculating when you create a volume and start adding directories. It starts calculating go based upon the directory they're in, and that gets set unless you reset it. So let's say you start out with 10 nodes and you're putting files on them. Those files are going in directories, and it's figuring out based upon the directory where those files are going to reside on the bricks. If you add new directories, okay, so we start with your 10, add 5 more nodes. Those 5 nodes will initially be empty. If you don't manually rebalance it, it will only put new directories on those 5 new nodes. So essentially, they will not be completely utilized, and you will have to rebalance. You will have to call the rebalance command, which is going to have some overhead because essentially it's moving a bunch of files around that is not really I/O for you, but it's I/O for the underlying storage system. And that's a good and bad thing. That means when you add nodes, you don't have this sudden flurry of disk I/O just to move files around. And at the same time, it means you've got to manually do it. So it's a double-edged sword. All right, so I want to run through a quick demo of setting up GlusterFS. I think so. The first time I played with distributed file systems, I'll give you some examples. I spent a night setting up Sheepdog because Sheepdog required Chorus Sync to manage all the nodes and figure out what was up and what was not. So that took me all night long to do. I used Ceph, and I set up Ceph while I was sitting on a plane with Wi-Fi, and it took me, a 3-hour flight to set 4 or 5 nodes up and get them all running. GlusterFS is I think the simplest modern clustered file system to install. But let me tell you what I've done up front. So I've installed 2 virtual machines. They're running on one of my Cloud Stack instances in San Jose, and I installed GlusterFS, and I also created the file systems that I wanted to export. I created those as XFS file systems, and so that's essentially where I'm at. Actually, I've run through the demo several times, so. I will increase the font here in just a moment, because I know that's not readable. Is that readable? Okay. All right, so GlusterFS is installed, and it's running on both of my nodes. So I'm going to add another node. So essentially, I'm saying there's a peer. Look for a peer at that address. Really, I'd probably want to use names, but this is not taking advantage of names, so we'll use IP addresses. So now I can say Gluster peer status. And you'll notice that it says I only have 1 peer. Well, that's 1 peer in addition to this node. So Gluster is running here, the Gluster daemon's running here, and it's also running on the other node, but the number of peers is truly 1. And it's going to tell me about that other node there. And the peer is now in the cluster, it's connected, nothing's really going on. So, yeah. So when you're adding nodes, you're going to probe it, and it will add it to the essentially the trusted collection of nodes. One node. So the nodes will all know about each other. If I shelled into the second node and said Gluster peer status, it would tell me about this node. They all, if you run this on one, they all become aware of each other. So they start telling each other. Wow, network is lovely. All right, so the next thing we're going to do is create a volume, because the volume is essentially where we're starting at. So this is the actual storage that we're going to consume. So let's volume creates obvious. This is the name of the volume. This is the strategy. So this would be distributed, striped, replicated, striped, etc. We're doing replica, and this is the number of replicas that we're doing. And then I'm telling it where my where I want to, what nodes I want to put up. So this is not necessary. It will not automatically look at all of the peers. It's not going to automatically look at all the nodes. When you're defining a volume, you're going to tell it the nodes that volume lives on. And so Gluster1, which is this machine. So you see root at Gluster1, that machine, and then the other peer that I noted. And this is the file system path to that mounted XFS file system. And I'll get out of the way so you can read the next line there. That makes sense to everyone?
Does that path have to be an actual separate volume, or can it just be a directory as part of the volume?
It can be a directory as part of a volume. In production, I don't know why you would really want to do that. I can't think of a good reason to do that. These also, you'll notice in this case, they're the same export brick one. They do not have to be the same. They just happen to be because it was simple for me to.
Are there size restrictions? They have to be the same size?
Yes and no. So let's say you create it with 500 gigabyte disks today, and so you've got two 500 gigabyte disks. You could add a 1 terabyte disk as another peer, or as another brick in the volume. It's only going to consume 500 gig because it's doing a straight volume. If you're doing, there are some strategies around that. Essentially, you start aging out and moving the data off of the old disk as you bring newer disks in, and you end up with greater space. But realistically, you were stuck with you were stuck with the brick size that you began with, regardless of your replication strategy, or whether it's replication, distribution, or striping. You're kind of stuck with that initial brick size, which is all the more reason to start using multiple volumes if you can, because that's going to allow you to grow and not be stuck at something ancient. Yes. Yeah. So it's always going to come back to the smallest size, but it's also that original brick size, right? So the smallest brick that's there is going to be your limiting factor. You would still be stuck with the original brick size. Sure, each of the nodes knows what it is. I mean, when the volume's created, it's going to know, hey, I'm replicated. I am limited to what I am. So. It depends. So in replicated, that volume is set when we create this. that the size of that volume is set. Because we're doing replication, all we will ever do with this volume is replicate it, even if we increase the number of times we replicate it. If we're doing distributed or striped, adding more nodes adds capacity, right? But you still get back to that brick size. So even though you may have a 2 terabyte disk now, and your original brick size was 500 gigabytes, if you only add a single brick, it's going to look like 500 gigabytes, even though it's a 2 terabyte underlying physical disk or array of disks. All right, so we'll go ahead and create this. Failed. Export brick 1 as part of another volume. That's lovely. Gluster volumes. No volumes. So let's call. I'm going to cheat. So I've created this and destroyed it a number of times. And all right, so you'll see that I created that successfully. Please start the volume to access data. And somewhere. So, still have my comment. We'll start the volume, and you'll see that it started. Gluster volume status. And so then you can see, you'll see that we have self-heal daemon running. You'll see that it's running on both nodes, that there's an NFS server on both, and you'll see the 2 bricks. All right, so let's go actually do something with this. They're really small. Right. So I can theoretically do that. It's bad. But if we let's go ahead and actually mount. All right. So mounting this with type GlusterFS, and you'll notice I'm only putting a single node in there, and then mounting it to /mount Gluster. And so you can see Gluster1 is essentially the same size as my root file system because I mounted it to a directory. So we'll copy all the logs over. And so mount Gluster, we of course have all that log data. You can also go see that in and so in export you will see that as well.
If you write through that path, is it what the mount path is what the same?
I wouldn't do that, but I really wouldn't use the mounted path rather than trying to write to the individual bricks. I think bad things would happen. I've never tried it. Now you want me to. I counted and so copy. All right. So Yeah, it doesn't exist. So no, don't do that. Not if you care about. Yeah, I mean it's. It's going to end up being the entire path. There are precious few directories here, so log becomes part of it. Audit, GlusterFS, Puppet would all become part of it as well. And so we'll you can see how many bricks, etc., that I have. And you can also see the replication, etc. So, and essentially, it's that simple to do this. Admittedly, this is a very, very simple and very small replicated set of storage, but this is essentially as easy as it is. You can have this up and running in 30 minutes. Depends upon the types of files, the number of nodes, the bandwidth. So you can do InfiniBand for interconnects with Gluster, and there are lots of people who do that. Personally, that gets away from the entire commodity storage piece for me, so I find that a little less interesting. But you know, there are so many variables that me giving you any answer would be just patently lying to you. Sure. I don't think so. So essentially, it's assuming that you are on the same layer 2 network for all of the nodes. As far as file access, so client access, you could probably do that through a specific interface. But I don't think you're getting away from the fact that they're all going to have to be on the same layer 2 network for each of those interfaces. Yes? Um, 40-ish, and that's because I don't get to talk to people who do this in real production that often. There are places where that node count is in the hundreds, but people who are doing interesting work like that tend to not tell you what they're doing because, and I assume this is true at other places as well, it becomes a competitive advantage for them how they are able to do something as cheaply as they are able to do it, right? Sage, is that what you find as well? People don't want to give away how they're doing it so cheaply, so they won't come out and say, oh yes, we're using Ceph for doing this awesome stuff. That, yeah, I mean, so I know folks at Alcatel-Lucent who were using Gluster, and the only reason I knew is because they were talking about it in IRC. At the same time, I know that different parts of Alcatel-Lucent are using Ceph, and the only reason I know about it is because individuals were talking in IRC. You typically don't see people that you don't have a personal relationship coming out and saying, hey, we're using this awesome thing and it's making storage significantly cheaper for us because we're doing all white boxes rather than going to NetApp and paying them tens of millions of dollars for unscalable storage. Yes?
So one question I have is, so you mounted it by hand. How well was this built with auto mount? I've seen all mounters that never had an answer.
Well, I'll show you. There's my SSTAB, which is very ugly because I did it with cat. And actually, you can't see that, can you? So that works, but you'll also notice that that is, no, never mind. That is not a Gluster mount. That's just the file system mount. Yeah. I don't want to say hit or miss, because I think it's a little better than that, but
Yeah, I'm not
yeah.
asking about like having it. That's kind of what I'm talking about, like having LDAP.
LDAP
And
on?
like the auto mount. Like,
I don't know.
you know,
Yeah, sorry. Yes.
yeah, my only issue is the NFS is essentially free only,
Yeah.
and you don't get all the goodness, you know.
Well, you also don't get, if that one node goes down, all of a sudden you can't mount
Like with NFS, you
NFS.
have to do it directly to NFS.
Single node, which then has to federate it all out, which destroys that entire no single metadata unit philosophy. All right, so we're 6 minutes till the end. If you have questions, yes. Could. So, generally speaking, that is going to change effectively the metadata about a file, which may mean that it moves around. So, could be substantially more expensive than you would have with a traditional move. Yeah. Yeah. Very expensive. So essentially the question is, what happens when you rename a file and what happens when you rename an entire directory structure? And because that hashing is taking place based upon things like path, it may result in all of that moving around. And it's one of the downsides of essentially hashing things like that. Yes?
Pardon me. Let me get the mic to you. So when you have a question, raise your hand so I can find you. So here you are.
So when I used to run GFS, there was a distributed lock manager layer. It seems like you can export the file system from either node of the two nodes that you're running on.
Mm-hmm.
How does it handle the distributed locking of it?
I don't want to say eventual consistency, but so you can do file locking. You can turn file locking on so that essentially on access that file becomes locked to anything that isn't that client. But otherwise you have the traditional problems with clustered file systems in that you're competing for resources on different nodes. There are people who advise turning on file locking all the time. There are others who say, it depends on your workload. If it's read-only, who cares? So maybe it depends on your use case. Gluster is not good for highly transactional workloads. So if you are taking a file and modifying it 50 times a minute, that is not nearly as fun of a workload for Gluster as, I write 5 million files and I read them. I read them all over time, and they're just things that you shouldn't be using Gluster for in some cases, and something where it's going to be highly contentious writing of the same data or same files is one of those that you may want to reconsider whether Gluster is the right fit.
Even files in the same directory in GFS are a problem. Like the directory metadata.
So are you saying it was a problem because you were changing? Slowed it down. I haven't seen that particular problem. Maybe I'm not running at large enough scale to run into it, but I haven't seen that problem. I've seen the problem down to a single file. Haven't seen a problem at the directory level. Yes?
Let me get this one.
Okay.
Right, so.
Yeah, on the two-node cluster and clients mounting the two nodes, is there an order in which they go to? For example, if they have node number 1, node number 2, do they always go to number 1 and never to node 2 unless number 1 goes down? I'm thinking on
So theoretically, if you're using the Fuse client, it's going to go to the node that has the data, assuming that it can figure that out based on hash. If that is not the case, then it will essentially have to walk and figure out where that resource is located. So you're not talking directly to node 1 and only node 1 for all file access. Although you could be. You're looking for the node that has it, and that may or may not. In a replicated state, it should have all of them. It should have all of the files, but it's going to figure out where and that node will respond. But I don't know that there is a deterministic access of nodes.
I'm thinking of an application that uses the same file system mounted on all the clients. And then client number 1 makes a write. Client number 2 looks for that file immediately or almost immediately. But the first client goes down. The node number 1 goes down, which all the clients are pointing to.
Mm-hmm.
So how does the file system figure that out?
So it is that entire eventual consistency problem, really. Essentially, because you're replicating, that file may not be replicated across all the nodes, and you may or may not have tolerance for that in your cache configuration. So maybe it's there, maybe it's not. Again, there are places where Gluster is quite honestly not a fit. If you have very low tolerances like that, it may not be a perfect fit. So, yes.
Yeah. So, shoot, I've kind of forgotten exactly how I wanted to phrase it. Say you have a workload where it's read heavy, so that's good, but some files are more popular than others, and they're fairly large files, say 10 gigabytes. Is there any way to make sure those don't become hotspots on the system, or
so you're essentially talking about intelligent load balancing based upon demand, and the answer is you can tune things like cache to keep files in memory, but past that, not really. I don't know that anyone.
You can't say like, replicate this to more nodes.
Yeah, replicate this one file to more nodes. No.
Yeah. So you would but you could like break it up into different file systems maybe.
Sure.
And then chunk it that way.
Different volumes, yeah.
Yeah, different volumes. So popular files, not popular files.
Yes.
Okay.
All right. I apologize for running right to the wall. Thank you very much for coming. If you have questions, I will be happy to give you Echo's email address rather than mine. But have a good day. Thanks.